So here we have a conventional electric generator. This is a DC generator. And regenerative braking, or generator armature reaction, is a counter electromotive torque that is produced inside the generator when current flows from the generator to a load. And here we have a light bulb. Now, when load current flows from the generator to the load, the current that's flowing from the generator to the load establishes a magnetic field inside the generator, which produces a counter electromotive torque, and this torque tries to turn the generator in the opposite direction that the prime mover is turning it. So if I operate the generator on no load, on idle, we can see that it is extremely easy to turn the generator's rotor. However, when the generator is placed on load and current flows from the generator to the load, the amount of energy that's required to turn the generator has increased significantly, and it's quite hard to turn the generator. Now, the more current that flows from the generator to the load, the greater the magnitude of the counter electromotive torque produced inside the generator, and the more difficult it is to turn the generator. The novel aspect of the RegenX generator is that the energy required to turn the generator on idle is the maximum amount of mechanical input power that is required. When the RegenX generator delivers load current to the load, whether it's an AC load or a DC load or recharging batteries, regardless, the maximum amount of mechanical input power is required on no load. And when the RegenX generator goes on load, it creates a complementary electromotive torque, which basically turns in the same direction as the prime mover, which is turning the generator, and the burden placed on the prime mover is reduced. It is not increased, and this is what we've demonstrated with the demonstration RegenX generator prototype number 1 and the RegenX generator prototype number 2. When the RegenX generator goes on load and delivers output current, it does not require an increase in mechanical input power to the generator as is required in the conventional generator mode of operation. So this means that when the RegenX generator is placed in an electric vehicle, the RegenX generator can recharge the batteries without decelerating the electric vehicle, and the magnitude of output current from the RegenX generator is irrelevant. The more current supplied by the RegenX generator, the greater the reduction in prime mover motor input, and obviously the greater the range of the electric vehicle.